Hey guys, how's it going? I hope you're all doing well, and I'm looking forward to starting this stream and seeing how this goes. So, and this stream, what we're going to be doing is finally procedural generation. But before we can start that, we're going to have to do a chunk generation. So we're going to have to do multiple chunks and stuff. And how's it going, Flare YouTube? And I'm doing good as well. It's good to see you guys here. So I have not done anything to the code in my off time. I was going to like refactor stuff and everything, but as you can see, it's still pretty much the exact same thing that I left it as before. And what's up, Voxel Riffs and Tree? I hope you guys are doing well too. So in the last stream, we had it where, yeah, we've got like the interior of the chunk cold. So the faces get removed on the inside, which is good. That's a good starting point. Now I want to basically get it so that we can generate a chunk radius, just so that we have something to work with once we start doing multiple chunks. So that'll be good. Okay. So that should be relatively easy, hopefully. Because of the way we've set everything up, we should be able to just get multiple chunks going by adding a few more structures and stuff. So if I go into chunk.h, we may have to refactor a couple things, but it shouldn't be too bad. I say that every time, and then it ends up being pretty hard to do whatever I'm trying to do. So we'll see if it's actually not too bad this time. Okay, so we've got a chunk, and this basically just has a pointer to a bunch of int16s. That is the data. And then we have this generate function, which just goes through and does this thing, which basically generates this chunk render data. And if we look at the bottom of this, this basically just returns all of the generated stuff, and it returns the vertex size and bytes, element size. Okay, yeah, so it just returns basically all this stuff, which is good. It's sort of what we want. So first thing I'm going to do is change this int16 star to something a little bit different. And a .h file is a header file, Flare YouTube. So basically in C++ you have .h and .cpp. If you were to think of it like Java, it's sort of like, and Java, well, I guess there is no relation to Java and stuff, but it's basically just where you define all of your like public functions and stuff. And then the CPP file is where you implement them. So, yep. But I was doing some calculations off stream and everything, and I basically decided that we're going to have 64 bits per block. And the reason I decided on 64 bits per block is because we can have 16-bit integer for the ID. So that gives us 2 to the 16th possible blocks, which is just an outrageous number. I think it's like 2 million or something. So it's a big number. We'll never run out of block types, so that's good. What are the other bunch of bits for then for a block? Well, we need to have at least 4 bits for the light level, right? Because light level goes from 0 to 15. So 2 to the 4th should give us 16. So we should get all of our light levels with 4 bits. And then we also need some other bits for just other odds and ends, right? Basically, we have rotation. We can encode rotation probably in another 4 bits. So that could be like direction. We definitely don't need 15 for that. Like we don't need 15 different things, but it's good to have the extra stuff there. We could also have like another 8 bits allocated for like block type, which is good. So that gets us another 16. So we're up to 32 at this point. And then we have 32 bits left over for just extra stuff that we may need to add in later. So I think 64 bits is a pretty safe number. And I also did the calculations thinking about like for the future. So like for multiplayer and everything. So will I add mobs to the game? I will do that. No RGB lighting. We probably will have RGB lighting. We have 32 bits extra. And we want to make an integer and bitwise all of these values. Yes, so that is the plan tree. And how's it going, SE Woods? I'm glad you guys are here. So, yeah, so we've got 64 bits per block. And I decided on this magic number too, because once we go multiplayer and we start streaming stuff and dealing with Wi-Fi, we're gonna have to like limit the chunk data as much as possible so that we're not sending outrageous amounts of data and players can play without lag. So if we have 64 bits per block, that is, there's 8 bits in 1 byte. So that's 8 bytes per block, right? And then there's 255 blocks per chunk. So we have 255 times 8 bytes per chunk. I forget what this is exactly, but it's a pretty low number. And what we end up with is something like 15 megabytes for, I think it's like a 4x4 chunk radius or 5x5. So, and it might be lower than that. I did the calculations and stuff and was pretty happy with 64 bits per block, but in the end, what this means is we'll be able to make a like 25 megabit per second connection pretty easily for this. And I guess it's like megabits per second. It's weird, but anyways, yeah. So with 64 bits per block, we should be pretty safe for most connections, and we shouldn't have to worry about like sending too much data or anything. So that's the plan. And can I make a 3D game engine tutorial? We'll see about that. I hope Minecraft will be sort of like a intro to 3D type thing. So the Minecraft series is going to be the next tutorial series, and we can hopefully do that. And 2408 bytes for chunk, so almost 2 kilobytes. Thank you, Tree. Yep, so about 2 kilobytes per chunk, and we should be pretty good. In 2048. Okay, yeah. So no matter what, we should be pretty good. So yeah, 64 bits, and I'll sort of leave this for now. So with all that in mind, let's go ahead and we'll say struct a block. And so, like I said, we're going to have, and also, I should mention this too. I chose 64, not kind of arbitrarily. It's always good to have your things in multiples of like either 64 or 32 for most modern machines. Most modern machines are going to be 64-bit. So having a 64-bit per block means we'll get optimum cache efficiency. So like we shouldn't have to worry about cache misses and stuff as much, which means we'll also get extra performance boost when people are playing on their local machine. 32 is also good because that means you can fit 2 of them. I think you can fit like 4 64 bits or 4 64-bit chunks per cache line. So like you should be able to get 4 of these in one go. And so it just speeds up efficiency and everything. But yeah, that's why I kept it to 64, and that's why I'm keeping this 32 bits of extra stuff. But yeah, so we got int 16. This is the ID, and then we're going to have int 4. I don't know if we have an int 4, so we may have to like do a bitwise OR there, which we can do in a little bit. This will be the light level. And then we'll have an int 8. We'll do rotation. So I'll just keep it like this for now. And then I'll just do like int 32 extra stuff. Or I guess we could just call this padding for now. So this should add up to 64, and I'll add in the block types and everything as we add more stuff. For now, we'll have int 8 as the lowest thing. And if we get really restricted on memory stuff, we can combine this and rotation into one int 8, and then we can sort of do bitwise operations to get that stuff out. But yeah. Okay, so when I get to the multiplayer part, will it be possible to follow it coding in Java, or will it be specific to C++? I have no idea, honestly. So like, I've never done multiplayer coding before, so it's going to be completely new for me and for you guys. I've done a little bit with like a pre-built engine, but I've never done it like from the ground up. So I'm not sure what support there is for C++ and Java and everything. I'll just sort of be learning as we go along. And am I going to be doing compression when saving this? Yeah, so Huyas, I think that's how you pronounce that. I hope I'm right. That's another thing I was thinking about. So when we load this onto disk and everything, we don't want it to lag when players are like moving through the world and it starts loading new chunks. And so my plan is we can save like 5x5 chunk areas or bigger, and then we can zip these up into like a .zip file. And then what I want to do is, since this is such low memory, we should be able to load this into RAM. And so I want to load in like surrounding chunk areas. I'm going to switch to the drawing screen because this is actually going to be a little bit easier to illustrate with drawing. So, yep. And let's go over here. I got to remove my video for this because I was changing up some stream settings, but we'll do that later. Okay, so basically we're going to have like this main area, and say the player is in the center of here. What I want to do is basically we can load up adjacent areas. And so we'll basically just load up this grid of areas, right? And this will all be in RAM. And then when the player moves here, we unload these areas, and then we load in these next areas. We won't necessarily be rendering the surrounding areas, but we'll have them loaded into RAM. That way, as the player moves from area to area, we can quickly load in new stuff. since it's directly in RAM already and we won't be dealing with like loading from disk. So that is the plan. We will see how it goes. And I'll have to do some experimenting with a bunch of different stuff just to see if we can get that working right. Yeah. So this is like the sort of the overall plan. For now, we have to actually start generating chunks and everything, and then we'll see where it goes from there. But yeah. And yeah, zipping is quite manual. So we'll see. I might do my own compression algorithm where I might use a zip library. Everything in time. So, okay, anyways, though, we've got this structure for a block. And instead of this returning int 16s, we're just going to return a block pointer, which is all of the data. And then we can just change this up a little bit. And we can say chunk data equals a block. And we'll allocate that. Okay, so we should allocate that much memory for blocks. And then we zero the memory so that it's all set to 0, which is good. Let's see. Just want to make sure that I'm not going to break anything. Okay, so... Okay, this is just a forward declaration. I was like, what the heck is that? Okay, yeah, so we allocate the memory, and then we go through and we initialize all of it to this stuff. So instead of doing this, what I'll say is block ID, or just ID. And we'll initialize that to that stuff. And for now, we're not going to use the other fields until we actually get into it. And then we get the vertex data. That's fine. Elements. Cool. And then this will be get block. This will actually return a block instead. And we'll have this be a const block reference. So I'll have this return a const reference. And this will have to take in a block pointer instead. Cool. And so we basically return the null block, or we return this data index, which should be fine. What's this saying? Okay. I don't know why it doesn't like this too much. So we basically get the index, and then we... Okay, there we go. It was just Visual Studio being weird. Okay, anyways, we need to change null block too, because this needs to be like an actual block. So let's go into there. This is going to be a block. We'll go into here. This is going to be a block. And we'll just change this to be an array initializer. And we need to include chunk inside of here. So we'll say hash include chunk.h. Should be good now. There we go. So if we go back into here, let me just look at this. We need ID, light level, rotation, padding. Okay, so if we just do 0 for everything, we should be fine. So 0, 0, whoops, 0, and 0. Okay, cool. So that's our null block. We should still be fine with that. Going back into chunk. Am I still using resharper? I am not, tree. It was like crashing random things on my computer because of how much RAM it was using. And I have like 48 gigabytes of RAM, so I don't know why it was doing that. But yeah, I had to get rid of resharper, which was kind of sad, but you know, you have to do what you have to do. And thanks, Flare YouTube. Okay, so we return null block, or we return the data index. So we should be good here now. This should return a const ref. This says it has 2 overloads. Did I mess something up? So, okay, that should return const ref. Oh, this is block map. Okay. So, oh, this is block format. Okay, wait, so what's going... Okay, I just have to change this. So this is going to be block now, not block ID. And then we can say int block ID equals block.id. Okay, cool. So we should be good there, and I think everything else should be fine. Okay, so this is going to return a block now, so I'll just change that to .id, .id, and same here, and here, and everywhere else we have this. Hopefully we can automate this somehow in the future. We'll have to see about different methods and everything, but hopefully we can. Okay, cool. So I just refactored a little bit. Hopefully we shouldn't have broken anything and it should still work. We'll see. So looks like it's working. And yep, looks like that worked fine. Cool. We've still got different block types and nothing broke, which is good. And yeah, you have 16 gigabytes of RAM, but ReSharper likes to crash. Yeah. And it's weird. ReSharper will like crash my browser. I don't get how that happens. So I'll be running ReSharper in here and then all of a sudden my browser crashes. And I was like, okay, I'm not going to pay for this if it's going to break stuff. But yeah, okay. So we refactored that. That worked out good. Now we want to generate multiple chunks. So we have this structure which just holds block data. Do we want to hold the chunk render data inside of here as well? I think we probably do, because that's going to save when we need to generate new chunks. Yeah, I think we're probably going to want to hold that inside the structure itself. And ReSharper has had optimization. And you got 16.2, but we'll be rebuilding your PC soon. Yeah. So rebuilding PCs are fun too. Okay, so I'm going to say let's hold the chunk render data or data inside of here. And this is just render data. And then this will be void now. And this will just generate the chunk data and the render data. That way we can just sort of use that. And this should be fine. We don't have to hold a pointer to this because if we look at this, this is already just a structure of a bunch of pointers. So we should be fine there. Okay, cool. So if we go into here, we'll just change this up a little bit more. So we've got this generate, and this is going to be void now. And this is chunk data. Okay, that's fine. And we got vertex, and I think we're going to have problems. Well, actually, no. At the bottom here, we can just say chunk render data. Okay, yeah. So instead of doing this as ret, we can just say this is, let's see. I called it render data. And that should be all we need to do. And then we'll have to change it up in world too, just so that we're using that now. So if I go into the top of here, yeah. So I say data equals chunk.generate. We no longer need to do this. Because it'll be within the chunk itself, which, yep, I have right here. So then if we scroll down, or actually, no, I have to remove data up here too. So remove that. And then we're going to have a problem here. So we'll just change this to chunk.data or render data. And then we're also going to have to say chunk.generate, just that we're generating that. Okay, cool. And then chunk.render data here too. Okay. There we go. So that should be another refactor done, and we should still be fine if I rerun this. Okay, so that looks fine. Sweet. That worked out good too. I'm going to move myself to the top of the chunk too in a minute here, just so that we can actually see. And was Minecraft an online game from the start, or did they add it when popularity grew? I think Minecraft was online from the start, or at least it was intended to be online from the start, because Notch was building it based off of Infiniminer, which was an online game. So I think that was the plan. It may not have been at the very beginning. But yeah, if somebody else knows, they can put in their input too, because they might know more than me. Okay. So we have this chunk generator, and okay, and I was going to move the camera up a little bit. Yeah, so let's just move the camera up higher, which, okay, I said it right here. So I'm going to move it up to 255, just that we're above the chunks when we generate, or when we fly in. Yep, cool. So we are above the blocks. I'm going to go 2 higher, just that we're at the very top of it. This way, once I start generating multiple chunks, we can actually see, and we're not like stuck inside one. Cool. So that's good. Just at the top of that. Now we need to generate multiple, and we need to store them somehow. So we're going to have to change the structure of our world a little bit, which I guess we can do inside of here. Okay, so we're going to basically want to hold a bunch of chunks in memory. And do we want to hold those as pointers? No, I don't think so, because a chunk is just a wrapper around pointers. Yeah, okay. So what I'm going to do is we're going to have a static chunk array. And I guess this is just going to be loaded chunks. And this will be an array of 16 for now. So we should have 16 loaded chunks at any given time. So that'll be like a 16 area around us. And that should be good to just get us started. And then right here, just remove that. We're also going to have to add in one more thing here, which is their world position. So how do we want to do this? Yeah, so I'm going to do glm vec3i. So we're going to have an integer. Come on, vec3i. Or ivec3, I guess. Okay. And this will be its world position. So when we generate it, we're going to take in x, y, z, and this will tell us where to generate it in the world. And then we're just going to store that here so that when we're rendering later, we should know where we are. Yeah. I like that. Okay. So we'll try that out. So up here, we will say this takes in X, Y, and Z. And this is going to be like chunk indices. So it's not like really world positions, but chunk indices. And what is an array? An array is just like a structure in programming. So it's like a container. And you should make the camera faster so when you're pressing shift, it's easier to fly for long distance. That's a good idea. We'll have to add that in just a second too. Cool. I don't think we'll be getting very many chunks loaded in and everything at this point, just because I still have to add a few more things to get that working right. But if we get to that point, that'll be a good idea. So, okay, so we have this int xyz, and I should probably call these something different because chunk x, chunk y, and chunk z, just so that we know which x, y, z we're talking about, because it's going to get confusing pretty soon. So chunk x, chunk y, and chunk z. Cool. So then first thing we need to do is change this into world coordinates. So we'll say int world chunk x equals chunk x times 16. So I think this should be good. So basically if we're at 0, 0, 0, then world chunk x would also be 0, 0, 0. So that goes to that. And then if we were at like 1 to the right, then that would be 16, 0, 0. Okay, yeah, so that should be good. So we basically just go up by 16 and then we go negative 16. And this will sort of be what we add to our x and y coordinates just so we get the right coordinates. Okay, so world chunk y equals chunk y times 16. And then we'll have int world chunk z equals chunk z times 16. And these are going to be const because they're never going to change in here. Okay, cool. So that should be good. So we've got this chunk x and all that stuff. So now we just have to change the way we calculate positions very slightly. So we're adding this, and then basically what we want to do is just add to our xyz's. Okay, so let's see. We do like x minus that. Yeah, and then we can just say plus world chunk x plus world chunk y and plus world chunk z. So now we should calculate them in world coordinates. So this is sort of like local, and then this is adding to get to world coordinates. And then all of these are calculated based on this initial one, so we should be fine. Cool. I'm also going to remove all this because it looks like we don't need it anymore. I'll leave this in just in case we ever get here and like fail. So I'll just add that. Okay, cool. So we should be good there. We have this x, y, z, and then we also want to assign those. So we'll say world position dot x equals chunk x, and we'll just do this. I guess we could just say world position equals, and then we'll say chunk x, chunk y, and chunk z. Okay. So that should be good. Now we have all of our world positions stored, and we should be getting unique things. So if we go back into the world, we've got an array of chunks which we want to generate around our player. So instead of doing this, what we're going to say is for int I equals 0 until I is less than 16, I++. And I guess we should change that 16 to be like a static constant, number of chunks equals 16. And then we can use that there and there. Okay. And where are we going to generate them? Well, we want to start at 0, 0, and then we'll kind of want to spiral out. So got to think of how to do that. Or we could just, or I could just do like a 2D array. So we'll say for int y equals -2 until y is less than 2, y++. So that should give us 4. And then for int x equals -2 until x is less than 2, x++. So this should just give us a chunk radius. Oh, and a chunk doesn't need a z position, does it? I wasn't even thinking about that. So this just needs to be a 2-dimensional vector because chunks don't have any verticality. It's just xy. So if we go back into here, we can get rid of that. We can simplify this. And we can simplify that. And we can remove that. Cool. Okay, and then for the z's, well, we don't care about that. Okay. So then going back into world, we just want to say, we'll go chunk index in here. So we'll say int chunk index equals 0, and we'll just increment that each time. So this should give us 16, right? This is going from -2. So -2, -1, 0, 1. Yeah. And then that's 4 times 4 is 16. So we should be good. So this will be chunk index ++ at the end. And then we'll say chunks or loaded chunks, chunk index dot generate. So we generate all the chunks. That's a typo. So we'll remove that. Oh, that should be y++ there. Okay. And we also need to generate in an xy, so we just pass in the xy. Cool. So that should be good. Our render state, we're going to have to come up with a way to render multiple chunks too. I think this calls for an abstraction. So we basically want to have like a chunk renderer, which just takes in some render data and renders it. What do we do now? So we say, we call this. This just sets up a VAO and an EBO and just uploads everything. Okay, yeah, so this is pretty simple. And then we just render it. Yeah, so I'm just going to go into here and then we'll create a chunk renderer. .h. And this should take care of all that. And I'm just going to change this to this. Just so that we have Linux support too. Okay, cool. So we can say namespace Minecraft, namespace chunk render. And this will just take in a, so we can have like a setup render state. Yep, so that's fine. And then this will take in a const chunk reference. And I'm going to do a forward declaration here. So we'll just have a struct chunk. That way we don't have to include it. And then I'm also going to include core. So this is a pro tip, I guess, in C++. Forward declarations are awesome so that you don't have to include in header files, which speeds up compilation times and makes your code a lot cleaner, and you don't have to worry about circular dependencies and stuff. So always do a forward declaration if you can. Yeah. Okay, so we set up the render state, and then we also want a void render function, which I guess we can just take in a chunk here, and that should render it. Yeah, cool. So that should work up fine. We'll make this more advanced in the future and stuff so that we can deal with things like transparency and stuff. But for now, we're going to keep it simple, stupid. So we will add in a chunk renderer, CPP, copy that, paste it, remove that, and we'll just include chunk renderer, which I guess is in render. There we go. And remove that. Cool. So then we're going to implement these. So we can do that, implement, and we're gonna have to include chunk up here. So that's world chunk. Okay, and then set up render state, which we have in world.cpp. So I'm just gonna copy this, paste it right here. And we're gonna have to like a remove chunk too, so that we're not, you know, storing a bunch of leaked memory on the GPU and everything. So we'll have to add that in once we get to loading and unloading chunks and stuff. Okay, but anyways, we've got this chunk and we want to do the chunk's render data. So I'm actually just gonna say const render data. Yep, chunk render data ref render data equals chunk dot render data. Come on, autocomplete, you can do it. Nope, it's not going to do it. What's wrong with this? It says incomplete class, but it's not. I have it included right here, right? Yep, this is a chunk. Oh, is a chunk a struct? Yeah, it's a struct. Okay. Yeah. I don't know why Visual Studio. Oh, it's because this is in a different namespace, isn't it? Yeah, okay, that's what I did wrong. So, pro tip, when you're declaring forward declarations, make sure you put it in the right namespace, otherwise you get problems. Okay. Anyways, so now we should be able to get IntelliSense. There we go. So this is going to be render data, and we should be good there. And then we'll just change data here to render data. And we can make this a const express because this is all going to be the same. So we will do that in the future too. And we want to upload the shader, the graphics ID for the texture. Why did I do this here? Let's see if I can remember why this was important. So I upload the texture, which is not chunk dependent. Yeah, so that doesn't really matter. Okay, so I can get rid of that. And we'll go put that into world.cpp. I guess I'll do that like right after I generate all the chunks. Yeah, I think so. Okay, so I create shader up here and then all this stuff. Yeah, I can just move that there. Okay, so that should be fine. And then we have the shader and everything. I'm gonna move it down just a little bit below the camera initialize. So this is just upload the world texture. And if we ever add in shader support for like multiple shaders, we're gonna have to change this up too. Okay, so this render state is actually gonna be chunk, or actually I guess chunk renderer. Huh. Okay, so we're gonna have to come up with a way to do this too. So inside of world.cpp, what I had was this render state thing, which was just this render state. And that was simply the VAO and the VBO. I'm going to remove this for now because we don't really need it. So VAO and a VBO. And then when we rendered, we could use that VAO. Yeah, so that's what I was doing here. So do we just put the render state in the chunk? I think that makes the most sense. So we just copy this render state thing. We'll put that inside of chunk.h. Right above the render data. And then we can just have render state. Render state. Cool. So that'll work. Now we have the render state inside there. And when we're generating the chunk, do we do that? No. So when we're doing this. Okay, so I guess this should probably be part of the chunk generation. Should it, or should it be part of the render? I'm going to say this is going to be part of the chunk generation. We'll tweak things in the future if we think we need to. So for now, we're going to copy that one more time. And then inside of here, I'm going to say have a static function up here. This will be static void upload to GPU. And this will just take in a chunk reference. And then we'll just kind of go down here. And we'll add it right above this guy. And copy this stuff. Paste it there. Okay. So this will just do that. And then we also need a chunk render data. So we'll take that. and that's going to be that. Cool. So last step will be to upload it to the GPU. And then at the end of this, we can just say chunk.renderState, or I guess chunk render data. So chunk, or I guess just render data dot state dot VAO equals VAO, render data dot render state. Actually, we could just do this inline. We don't even have to do it there. Instead of doing this, we could just change this to render data dot VAO, or render state dot VAO. Cool. So it's a little bit of a mouthful, but I like that better. And then instead of doing a VBO here, we will change that to that. And copy that. And that. And then we don't even have to return anything. Cool. So that should be good. And then at the end of chunk generation, we can say upload to GPU, and we'll pass in the chunk, which is this, I guess, isn't it? Yeah. So this is a member function. So we'll just say star this. Okay, cool. So, you guys are saying, does the newest consoles, Xbox Series X and PlayStation 5, have Java support? Yeah, I don't think consoles have Java support. Yeah. Microsoft is pretty annoying too when it comes to like Xbox stuff, just because I think if you want to develop Xbox, you have to use DirectX. So you can't just use like OpenGL or Vulkan or something. So it's kind of annoying because you just have to support it. I might be wrong in that. If somebody has experience with developing Xbox stuff, they can correct me too. But a little bit annoying, but you know, it is what it is. Okay, anyways though, so we upload the chunk to the GPU when we generate it. So we no longer need this thing. So instead the chunk render will literally just be rendering chunks, which I guess it makes sense then to not even have a chunk render and just put this inside of here. We could just say void render. That's a lot simpler. So then we'll just delete this. We will delete this as well. And we can go into here and just implement a render function, which will be pretty simple. We'll put it right here. And this will be chunk render. And we'll go into world.cpp and steal that code, which is just this. So yeah, we go here, go into here, and we need render state, which is part of us. So we can say render data dot that. And then this is just render data. Cool. So we have everything sort of abstracted out. We should be able to do multiple chunks now. If I remove that. And oh, and C# can be used on consoles. Cool. That's pretty cool. With like mono game, I assume. Okay, so now when we have our update function, instead of doing this, we'll go for int I equals 0 till I is less than number of chunks, I plus plus. Chunks or loaded chunks, I dot render. And that should be good to replace that. And then we can remove this because when we generate it, it will generate that. And now we can remove this and this. We still need to load the world texture. I guess if we're loading the world texture, it makes sense to actually load it into the shader there too. So I'll move this below shader. And then we can move this to that function. So that's all a little bit consolidated. So we'll do that. Yeah, okay. Or should I do that? Wait a second. Okay, so we say world texture equals this. Well, that's kind of stupid. We should just change this to that. And then we can just have this be void. And this will just be world texture instead of all that. Okay, and then I'll just do that. Remove that. Now we should be good. And then I just have to change this. Okay. So that should load it, upload it to the shader. And then we update and we render at the end of the update function. Okay, let's see if this works. I will be very surprised if it does, but you know, this stream has been going pretty good. We've worked like first time on the other two things too. Oh, Okay. It is working. I just forgot that X and Z is actually the thing that we want. So, because Y is vertical. I forgot about that. Cool. So if we just go into chunk.cpp and we change this. So I guess we can still refer to this as like chunk X. I'm going to change this to chunk Z. It just makes a little bit more sense. Whoops. Go back up there. So that's chunk Z, world chunk Z. And then we just change that. And then we'll change that so we have no confusion. Change that. And inside of here, we can remove that. And this will be plus world chunk Z. Okay, and then inside of application, or I guess it's inside of world. There we go. Right here, when we generate it, this will be Z and Z. And then this will be Z. Okay, so now if we do this, we should have it working. Hey, look at that. Now we have multiple chunks. That's pretty sweet. I think this has been the easiest stream so far. Things just seem to be working for now, which is really good. So now we have the ability to create multiple chunks and just sort of load them in. So now we can get started with procedural generation, I guess. We'll start on this little test area and then we can start moving up from there. And if we go in, you'll notice that we're not culling the block faces between chunks. We will extend our algorithm to work with multiple chunks so that we can like inspect the chunk next to us and then see if we need to cull the face or not. But yeah, for now though, this is pretty good. Cool. And I guess I should probably change this top block to be grass again, but the grass has a weird texture, so I'll wait on that a little bit. Okay, so we're going to need to do Perlin noise, and I have no idea how Perlin noise works. So let's go pull up our browser, and we're going to say Perlin noise library, C++. We might actually use, I think it's like Perlin X or X noise or something like that. Noise X, SimpleX, that's what it is. It's like the updated version of Perlin noise, and it's a little bit faster. So this guy says this is, I'll zoom it in a little bit if you guys want. Perlin's classic noise. Yeah, so this is basically just the improved noise algorithm. It's faster. And I guess it's a little bit better. Yeah, cool. So this is what it ends up looking like when you do this. The C+ implementation is based on the Java version. And it's a, let's see, what's the license? MIT license. Cool. So we should be good. Current status, we have 1D, 2D, and 3D noise algorithms. That's pretty cool. Brownian motion, also cool. It's CMake though. I hate that. I really don't like CMake, guys. So yeah. Perlin noise is easy. We can help you. Thank you, Asher. Cool. Do you guys know SimpleX noise too? Because that would be great. So they want to implement 4D noise, but they don't have that yet. So this is compiled with GCC and Clang. Seems to be good with Windows Server. Let's see how complicated his library is, because if it's complicated, I just don't feel like dealing with it. Okay, cool. It's just 2 files. This guy's a winner. Okay, so we're going to be using him. Let's go and do Minecraft vendor. We're going to add it in here. So we'll do a git submodule. And I've gotten better at git, guys, so this should be pretty easy. So you can say git submodule add. We'll grab that link, paste it into there, and I want to add it to, let's see. So I need to add it Minecraft vendor. And then this will be our SimpleX. So now we should get SimpleX here. We got the clone. That's all good. So now we have all that version controlled, and now we just need to update Premake so that it uses this. So let's go ahead and say Premake right here. So we've got the start project. We're just sort of adding all of our files to this, which you know, I'm fine with. If we go into here, he just had 2 files is what it looked like, which is amazing. I love it when people do that because so much simpler to just add this stuff. Cool. Okay, so we've got the SimpleX, and then we've got source, and then we've got that. I might make an include directory and just change up his thing a little bit. I don't know, because I hate it when they don't do like an extra directory in here, like SimpleX here, so that you can just use it. And say like SimpleX / whatever. But for now, I guess we'll just leave it as this. Okay, so anyways, let's add this here. We'll do 2 here. So this is gonna be in SimpleX, and then source. Right, let's just make sure I got that right. Yep, SimpleX / source. And this will be star.h and cpp, I think is what it was. Yep, cool. So we're going to add that to our Premake build, and then we can go ahead and just say include directory vendor / SimpleX / source. So we're just going to sort of have to use it as is. Okay, and that should be good. So now if I go ahead and just build this again, we'll go command prompt, build that, and now we should be good. Whoever said that C++ libraries are difficult, right? They can be easy if the library author makes it easy. I spent like the past week trying to get FFmpeg set up, and that was the biggest pain in my life ever because they just made that library so hard to set up on Windows. So yeah, I eventually just installed the binaries and wrote like a utility to just install it because I was so sick and tired of it. But yeah, okay, so we've got that. Let's go into core. And then we're going to go ahead and just add SimpleX here. We'll say hash include SimpleX noise. Cool. Does his library have like a usage thing too? So he shows all this stuff. No, he doesn't have a usage. I'm assuming the header file has like everything you need. So if we were to just go into here. Okay, yeah. So we just do SimpleX noise, and then we just say, cool, we just literally call this. That's really awesome. I love it when library creators just make things so simple. This is awesome. Okay, so we can just call SimpleX noise. We can call it with all these different values. Okay. Oh, this is like the fractal noise, I guess. Yeah. Okay, and I think this is what we want. This is going to be a little bit better. So we just construct this. And then we can call fractal. Maybe. Yeah, I think fractal. And then we can do this. This will be just so that we can generate like OR clumps and stuff too. Yeah, this is a very nice looking library. This is awesome. Okay, so I'll start with this and then we'll move up from there. So we'll do like a height map thing using 2D noise. See how that goes. And then we may increase it or do different things in the future. I'm wondering, does he have a way to seed this, or we just seed it ourselves? Yeah. Yeah, I think we just seed this ourselves using random numbers. Well, I don't know. Because I thought usually you would seed the noise generator, but it doesn't look like he has that. So we shall see. Okay, if we go back into world.cpp, we should have access to that now. Or actually, I guess in chunk.cpp. For now, what we'll do is get our height. So we'll say float max height equals, or actually, I guess we do that where we actually generate the blocks up here. So, and it might random seed itself. That's true. If it does, I won't like that because I want to be able to control the seed. So we'll run it a few times and see what happens. But we'll say float max height equals SimpleX noise. And then we'll do noise and we'll pass it X and Z. So that should give us a third float, which will basically be a number from 0 to 1, I'm assuming. Let's see. This takes around 150 nanoseconds. Cool, so that's fast. X is a coordinate. Returns in the range -1 to 1. Value of 0 on all integer coordinates. Okay, so should we be mapping the x and the y to 0 to 1, or does that matter? We will find out. But it returns from -1 to 1, so we just want to map it from that to a different thing. So I'm going to go into here. First of all, utils, and we have this math library. Do I have like a map function? Okay, yeah, I do have map range. Cool. So I am thanking my past self for doing this. Is this your house, Gabe, or can we risk spotting brother in the door behind you? This is my apartment, so no, we're not going to see my brother or anything. But yeah, I moved out like right after college and stuff, and basically just got my own apartment because I wanted to be alone and stuff. So it's pretty nice. And x and z are too big of increments. Probably you want to increment by like 0.02. Okay, thank you, Asher. So we'll probably divide by, I guess, 100 or 10 and see how that goes. So we'll keep that in mind. This map range thing is going to be helpful too, though, because we want to map from -1 to 1 to 0 to 1. So I'm going to say cmath map range. So we'll include up here utils /cmath. Cool. Map range. So the value is this value. So the minimum is -1, maximum is 1, and we want to go to 0 to 1. Cool. So we'll do that. That should give us a value from 0 to 1. And then I'm just going to go ahead and multiply that. And you guys can't see that, sorry. And I'm going to go ahead and multiply this by 255, which should give us some number between 0 and 255. Okay. And then we'll just say if y is less than max height, we give it that ID. Otherwise, it's 0, which should be good because then that means it'll just be an error block or whatever. And BlazeX, you are here. Cool. Thank you for showing up. And yeah, we are doing generation. We're actually getting to the generation part for once. And I probably know this already, but fractal will give you a much better result. Yeah, so I plan on using fractal to generate like the ore clumps and stuff too. We'll experiment with different stuff and everything too. I haven't done much with noise generation, so just sort of explore it and we'll see how it goes. But yeah, so we get the SimpleX, and this should give us a range from 255, and then we're just going to say if it's less than that, assign it to whatever. And this is going to be, yeah. Okay, so if it's less than, oh, okay, wait. So I also want to make sure that this says else if y equals max height, we're going to set it to that block. So that should be good. So this is like the, I think it's concrete. Green concrete. This is dirt, and this is just sand because I was just doing random stuff. Okay. I think that should be all we need to do. Let's just see what happens, I guess. And then I'll divide the X and Z by like 10 or something too in a minute. And if I put bright green or grass block, it's old Minecraft. That's true. The grass blocks that they have like a gray or grayscale top, so that's the only reason I'm not using it yet. I'll use it in the future once we get like a better shader to actually handle that. Okay, we got build errors. Let's see, was his build not really that easy? I can't, oh no, I just messed this up. Can't open world/input. Did I mess something up? That's weird. World/, did I lose a file? Did I delete one on accident? Core. Oh, there's world. Yeah, I don't have input in there. That's weird. Or there. Oh, you know what it is? I bet you they're in the wrong folder. Let's see. Is it in core? Oh, I moved it. Okay. That's weird. I don't know why I didn't get this error before. So this is in core now, I guess. Okay. So core/input, we should be good now. Let's see. And do you think you saw input in core? Yeah, thank you, Asher. Noticed that a little bit too late. I don't know. I guess I must have moved that, and for some reason it didn't recompile properly or whatever. But yep. Okay, so we're getting some weird stuff. Okay, yeah, so it's definitely doing the noise. And we're getting some weird rendering artifacts that we'll have to fix. But you can sort of see it's like, it is definitely generating noise. I'm definitely going to decrease the increment like you said, Asher. And we're going to have to figure out what's this weird gray stuff that I'm doing. So that's probably going to be in the chunk generation. So basically we just say get the block, and it should be like, oh, you know what it is? I should say inside of here, if block ID, I guess we should just say if block equals block map, maybe? No? Yeah, block map? No block. Okay, cool. Yeah, so we'll do that. And this will take in just a regular block, and we'll also do that. So I'm going to overload that equals operator, but if it equals that, we'll just continue. Cool. So then I'm going to go into block, and we're going to overload the equals operator. So we'll just say operator, actually bool operator equals equals. I think that's how we do it. And then this will just take in a const block format and other block. Okay, what's this say? Yeah, so that works. So I'll copy that. We'll go into chunk and implement this. This is another really nice thing about C++. You can overload operators, which can be bad, but it is super nice. So I'll just do that. That's the wrong syntax. I think it's right there. Nope, still wrong syntax. What's wrong here? Okay, so this says, but it does. Oh wait, no, this isn't in chunk. Whoops. This is in block. Yep, I think that's right. Let's move that back up here. And right here, because I think this is where I define, yep. And we'll just have to forward declare block format, I guess. Yeah, so I'm just going to forward declare that struct block format. If we go back in here, okay, there we go. No errors. And then we'll just return other block dot ID. Do we not have ID in here? That's kind of stupid. I think the block format should have the ID. Okay, so we'll do that. We'll update that. So other block dot ID equals this guy's ID. Cool. So then let's go into block format or block map, I guess. And we're going to add in an int16 ID, and that should give us an ID. Oh, and I just saw this. So create height map values. Oh, cool. You just gave me a height map values. Thanks, Asher. I'll experiment a little bit, and then I'll go back to your height map after I experiment a little bit, okay? So let's see. We've got an ID in here, and then... Oh, you're fine about the formatting, too. Once I paste it into Visual Studio, that'll fix it up, so it doesn't matter too much. Okay, so we've got this ID now. I want to add that whenever we generate block map, because that just makes sense. And this null block will also be block ID as 0. Yeah, so then this will be pushback, and ID, I guess, will be block formats dot size. Yeah, that should be fine. And then we can just cast this to an int16. Okay, cool. So that should be good. What's this saying? No block. Doesn't like that. What's wrong with this? Oh, okay. I don't have to do that again. Whoops. Okay. So that should be fine. Oh, wait. No block is a block. What am I doing? Okay. I don't even have to do the block format thing. Okay. So let's actually remove this because this doesn't matter. Go back into here. Remove that because that doesn't matter. And then we'll just go into chunk.h and just change this equals to use a block instead of a block format. Maybe it'll be useful to have the block format in the future, but for now, I should be able to just use that, and that should be fine. Cool. And and we no longer need to forward declare this. Cool. And thank you for following ABHI Infinity. Cool. So, do you have a degree in programming profession? I have a degree in computer science and math. So, I guess, yeah. I don't think degrees are worth their salt nowadays. Like, I had a lot of friends who weren't the best at programming and still got through with like lots of A's and stuff, and they didn't even enjoy programming. So, it doesn't mean too much. But that is JS code, so I'll need to tweak the syntax. That's fine, Asher. And coffee or tea? I drink coffee. I'm sorry about that. I like boba tea, just not regular tea. I don't know. And I like sweet tea and iced tea because I'm from the South. So I guess that's a given. Okay, so this should be fine now. And then we can just finally use this, right? This should be fine, yeah. So Minecraft block. That should be fine. Let's see. Did I mess this up? This uses a block ref. Oh, I have to change this, I think. The implementation. Wait, nope. Yep, this uses a block ref. Okay, that should be fine. I overloaded the operator for Minecraft block and Minecraft block. It says no operator matches block, but it should. It's very strange. Maybe I'll do overload the operator here, and then we can just say B. So this will be A, and that'll be B. Okay. And coffee likes you. Thank you. And you guys like coffee too. That's good. And yeah, sweet iced tea is good. And there is a difference between sweet tea and iced tea, especially depending on the version you get at like different places. I know me and my friends went to Montana and we got their sweet tea and it was not sweet tea. So depending on where you go, it makes a big difference. Am I using eigen for vectors and matrices? I'm using GLM, so graphics library, math library, I think. And you prefer plain milk. Yeah, I don't really drink coffee too much because I don't want to get like a dependence on caffeine and stuff. I had coffee this morning because it helps me wake up faster. But I typically will just drink water in the morning and stuff. So, yeah. But yeah, anyways, so let's see if this works a little bit better. Because for some reason it didn't like... Visual Studio was saying it didn't work. Okay, yeah, so now it's saying it's okay. Whatever. Cool. So we'll say this is A and B, and this is just a operator instead of doing a member operator because it didn't like that. So we'll say a.id and b.id. Cool. So that took way longer than it should have. If I run this again, we should be fine. We should skip the null blocks, which are just zeros. Oh. So that does indeed work. We're getting noise for sure. I'm going to do Asher's method, which was to simplify the noise a little bit so that we're not getting these huge changes. But yeah. And Northerners don't understand sweet tea. That is true. Yeah, they do like iced tea without any sugar. And it's just like, no, that's not how you do sweet tea. But have I created joints in Jade Engine yet? No, I have not. So I've sort of put my Cocoa engine on a bit of a hold, mainly because I'm working on my math animation library for like the 3 blue 1 brown project and stuff, which is actually going pretty good. I'll show you guys that real quick because I think it's turning out pretty cool. So if I just go into this math animations, I think I have a built version of it. So yeah, so I can run this. I'm working on outputting videos and stuff, but if I just start the animation, I can draw different curves and everything. And as long as it's in parametric equation form, you can draw any shape you want. So that's pretty cool. And I plan on improving this a lot more so that I can do like better animations and stuff. But yeah, so it's pretty cool. I'm happy with the way it's turning out, and I'll probably start working on my engine again afterwards. And anyone here already eaten pão de queijo? I've never heard of that, but it sounds good. And thanks, guys. I'm glad you like it. So hopefully I'll be able to make it easy to use and stuff. I got way off track. I tend to like get way off track when I'm coding projects and everything. So I made this bootstrap library, which basically will just go and download FFmpeg for me the binaries, and then it basically just puts it inside of this folder, and then it unzips it and everything for me, so I don't have to ship it with the OpenGL code. And it took me like a day to do, and it was completely unnecessary for the imaginary users that will be using my library in the future. But I just felt like I had to include it just to get experience doing it. So yeah, that was a waste of time probably, but I did it so that it'll be easier for people to use the library in the future if they ever use it. And I'm working on decoding things, but it does not work well. Like, I'm still figuring that stuff out. So yeah. Okay, anyways though, let's go back to Minecraft, because we're actually getting pretty close to having something that's working pretty good. Let me go to your code, Asher, real quickly. I'm going to scroll up and grab that just to see what you're doing here. So copy that. And Brazilian food and cheese bread. That sounds really good. I'm a huge fan of like Spanish food in general. So I love all that stuff. And by the way, when you put the formatted code in #general on Discord, if you want to see it formatted. Oh, thanks, Asher. I'm just going to paste it in here real quick, actually. So we'll do it right here, just so I can check that out. And maybe we can actually make a challenge of this. If you guys want to send me your noise generation, we can try them out and see what happens and see which one looks pretty cool. So let me just, I'll do that and that. Okay, there we go. Cool. So this says taken a, I'm assuming this is a float, the Y offset, and then this is create height map value. So I'll just remove this from the function. And we're probably going to use the X values and Y values that I've got. So this is just going X and Z is what I'm assuming. You can correct me if I'm wrong on any of this, Asher. And then we'll just remove that. And we'll do this. Okay, so noise XY mapping from 0 to 1. And what's this 100 here? Okay, so this Perlin open SimpleX or what? This is SimpleX noise, yeah. So I just got a SimpleX noise library and added it to my thing real quick. I didn't code it, so I have no idea. Yeah. And remapping to between 0 and 100. Okay, so you're mapping from 0 to 1 to 0 to 100. So that's sort of the same thing as this, except I'm going to 255. And then you have X offset plus equals increment. So, yeah. So what's this Y offset plus equals increment doing then? So you basically have the increment and then the X offset plus equals increment too. Are those to like improve the noise generation or anything, or? The Discord version has comments. Okay, cool. Let's open up Discord real quick. So I'm opening it up off screen, guys. Sorry. So I'd show you my Discord, but maybe some other time. Okay, so if I go into here, you have it in general with some comments. Okay. Oh, cool. And thanks for following this beat. Okay, so Y offset is for noise. This is the Y value passed into the noise function. I'm going to copy this just so that you guys can see it on stream. So if I just copy this and I'll comment it out, we should be good. Just comment all of this out. Cool. So you have all the comments here, and Y offset needs to be outside the loops. Okay, thank you. I will fix that too. So Y offset is for the noise. This is the Y value passed into the noise function. So then these loops fill the array with the Perlin noise map, creates integer between 0 and 100. And then the X value is passed into the noise function. Okay. And we take the value that noise outputs, which is between, and then map it between 0 and 100. And then we put it into the X and Y positions. Yep. And then we increase the X noise by a small increment. Okay, so that's what you're doing differently than me, is you're incrementing it by a small increment. Now, I do want this to be reproducible depending on the world. So I'm going to change up your algorithm just a little bit, which is, I feel like is pretty similar. Tell me if I'm getting this wrong, but instead of doing the increments, I'm just going to divide the X and Z by 100, which should do essentially the same thing, I feel like. And then just give us smaller increments, because it'll be like 0, then 0.01, then 0.02. So yeah. Okay, so let's see what happens when we do this. And I also have to fix, like, because we're not getting grass blocks at the top, so I'll have to fix that as well. No, that did not fix it. Maybe I just need to go smaller increments because it looks like it's a little bit better. Let's go divide by 1,000, see what happens. And we'll divide that by 1,000 too. Okay, it's definitely doing something. Oh, and all the chunks are repeating, so we're definitely... Oh, I know what that is too. I need to change it to use a different offset, but this looks like it's going pretty good now. First of all, I'm going to change the top block to actually be grass so that looks nicer. I feel like this should be doing it. So this says max height. Oh, and we should be calculating the max height outside, I guess. No. Yeah, that's fine. So this goes y, then depth, then width. And this is calculated based on x and z. If y equals max height, oh, I know what that is. So I just have to change this to an integer. So we'll say max height float. And then I'll say int 16, max height int, or actually just max height equals int 16. And we'll do max height float. There we go. So we just convert that to an integer. This way, this actually works. Yep, and then I'm just going to remove this. So we should be good there. And then what I need to do too is not just do x and z, but we need to do x and z plus the world chunk x and the world chunk z. So we're going to move this out just a little bit more so that we can actually see what's going on here. And then I'm going to do that and that. And that goes there. And then we'll just do that, that. And I'll just move that there. Okay, cool. So we're going to do SimpleX noise, x plus world chunk x. And we're going to do z plus world chunk z over 1,000. And then we're going to go from -1 to 1 to 0 to 1, multiplied by 255. We should map. Okay, let's see what happens now. And yeah, it's definitely tiling on each chunk. And 1 block equals grass, 2 to 5 blocks stone, dirt. Yeah, I'm probably not going to follow like the actual Minecraft IDs just because, you know, I'll probably do that later. But this definitely looks like it's doing some sort of noise. So if we take a look, it looks like it's just sort of going up. So it's not very interesting noise, but it is noise. I might try the fractal Brownian motion next and see if we get some better results with that. It looks like it's going in a pretty good increment though. So I think I'm happy with like the step size. I might have to change that up a little bit. You think the increments are too small right now? Okay, so we'll try over 500. I'll change this to like const int or float increment size equals 500. And just do that. So we'll change that. Okay. Let's see what happens now. Okay. Yeah, it looks like we're still getting sort of the same pattern. You guys think it's still too small? Yeah. It looks like it's just sort of going in this general pattern. At least it's the same every time. So that tells us they're not using any sort of random seed generator or whatever. Let's go 250 and see what happens then. It is an interesting pattern. It seems like it's just going up though, like just a hill. I hope it goes like up and down and stuff, which I think it will, but. Okay, yeah, so it seems like it's just amplifying what's happening every time I change that, which is pretty cool, but not the desired result. Is this open SimpleX? Noise library looks different from what you're used to. This is just this library I found right here. He said he based it off of, let's see. I might try the fractal Brownian motion because I think that's going to be a little bit better. Yeah, so this is fractal noise with 7 octaves of 2D SimpleX noise. So I might change it to use this and see if that works a little bit better. But yeah, he doesn't say what, he just based it on the SimpleX algorithm, I guess. And he said he based it off of Java implementation. Yeah, so we will try that. And have I heard of Ultra? It's a new Steam type of thing. I have not heard of Ultra. I just recently started playing some Steam games and stuff again, though. Used to play a lot more games and kind of dropped off, but I've been getting back into that, so it's fun. I'm working through Dishonored 2 finally, so it's a fun game. But yeah, okay, so we got this increment size. I'm going to change that back to 1,000, and we'll change to, instead of using SimpleX noise, we'll say, I think we have to do like a const SimpleX, is it SimpleX? Nope, it's not doing that. Let's see. Let's go into here because I think he has like an object that you have to create. If I go into that, okay, there we go. Yeah, so he's got an explicit constructor, which is just SimpleX noise. And it's part of the SimpleX noise. Oh, okay, that's what I was doing wrong. So if I go back down here, we should do SimpleX noise, generator. Let's see. It's not a type name. What did I do wrong? So this is just, oh, this is just a class. Okay, whoops. So we'll do that. That's generator. And we'll just say that equals SimpleX noise, which should generate his default values. And then we can change this to generator.fractal. And this takes in just size t octaves. Okay, so let's take a look at this again. So this takes in octaves and x. So this is a summation of 1D Perlin noise. And it returns from -1 to 1. So this is just one-dimensional noise, though. Oh, does he have a 2D one? Yeah, fractal XY. Okay, cool. So we'll change that to the XY one. And then we'll say octaves. I'll do 10, I guess. I have no idea what the octaves are or how they help, but we'll see what happens. And so the Ultra, this is a new platform that will compete with Steam. It's supposed to be indie and game-friendly. Cool. Thanks, Spyware HR, for following. It's hard to read your guys' names like immediately, and I have to be careful about that because I've seen some live stream names that aren't so good. But anyways, okay, so Ultra is an indie platform that will compete with Steam, and it's supposed to be indie game friendly. That sounds interesting. I'm interested to see how well it does and stuff, just because we've got like, you know, Epic with all of their, you know, their things to like entice indie developers and stuff. And I think, and like itch.io is pretty huge too. So it'll be interesting to see how it goes. And put your face cam on the button right. It's better for us to see things. What do you mean on the button right? So like it's over here right now. Are you saying, oh, on the bottom right, I think is what you're saying. So just, let's see. You think it would be better if I move this down there? And I'm going to move this too. You guys can't see this yet, but I'll change it in just a second. It's like that. Okay, and Asher said, just implement the same way I'm doing it in JavaScript with division by increment, and it works perfectly fine. Doing division as to say that isn't a problem. Okay, cool. Okay, cool. So this is a little bit better for you guys with the camera down here. I'll keep it down here for now, and we should be good. Put it in the middle. You guys think it'd be better in the middle? Oh, wait, because the reason I had it at the top right is just because I have all the errors and stuff down here, but you can't really see them anyways because of the chat, so I figure it's not that. Oh, I'm also going to have to move the alert box too, because that's going to be there. I'll leave it this way for the rest of the stream, and then we'll see if we need to change it in the future too. Okay. Now, we've got this fractal thing. Let's see if this works any better. According to his height maps, it looks like it should work way better. Okay, so already I think it does look better. It's still following like the same pattern and stuff, but you can see there's more like variety to it. Yeah, so this is definitely doing some different stuff now. And we're gonna have to like do some experimentation with like layering different noise patterns over each other and stuff. Let's go back to his library and see what he says too, because he says he made this thing, which is pretty cool. So this is with 7 octaves of 2D SimpleX noise. So let's try 7 octaves and see what happens. Frequency of an octave of noise is the width of the pattern. Amplitude is the height of its feature. Lacunarity specifies the frequency multiplier between successive octaves, and persistence is the loss of amplitude between successive octaves, usually 1 over lacunarity. I have no idea if I pronounced any of that right too, but you know. Okay, so let's try 7 octaves and see what happens. Maybe that's sort of like a seed too. So if we change the octaves, we can change the noise patterns. Yeah, I definitely hope I can seed it too. If I can't using his library, I can always like implement some sort of seed generator that just offsets the X and Y values. Yeah, so it looks the same. What we could do for now to get some sort of seed going is we can say hash include random. Yeah. And then we can go ahead and say, we're going to do this in the world actually. So we'll go into world.h and world.cpp. And so this will store like our int 32 seed. And we'll have this 0 initially. And then we'll include random here. That should be good. And then what we can do is use this as sort of like an offset for the X and the Y values. So then we can say seed equals random, or I guess it's just rand, which just returns an int. Rand, what does this do? Let's look it up real quick. C, random number. So this function returns 0 and rand max. Okay. So we'll go ahead and we'll say seed equals rand over rand max. And I know this probably isn't a very good random number generator too, so we can change it in the future if we need to. And then we'll cast these to floats. And then we'll multiply this by, I don't know, like 1,000, just to give us some sort of variance. And then we'll cast that to an int. And we'll do that. Okay, cool. So this should give us a random seed. And then we can just pass that seed into each of the chunk generators. So we'll do that. And then inside of chunk.h, we can go ahead and say, this takes in int seed. And what did I make that? That was a int 32. Okay, so we'll do that, which should just be an int, but you know. Okay, so we'll do that. And then inside of here, we can go take in the seed. And now we can go, instead of world chunk is like this, we can do seed plus that. Will that work? Yeah, that should be fine. Okay, and then we'll just do that. Now we should get random stuff every time we run, if the random number generator is random. And yeah, so now it should be slightly different than last time. I think we're probably gonna get the same random number every time right now, because we have to seed the random seed generator. And I'm just gonna go logger info world seed %d, and this will be the seed, just so that we can see what's going on. This, I'm gonna not log anything in here so that we don't get all that clutter. I know I'm logging something somewhere. Let's see. Oh, it's right here. Okay. So I'm just gonna remove those for now. Exit out of that stuff. So let's see what the seed is, and let's see if it changes up every time. And if it does, we should be getting something different. So this is sort of like the poor man's seeding something that's not a random seed generator. You can see we got a world seed of 1. Let's see if that changes this time. No, we got the same thing. So I think I have to seed this random seed generator. So if we say seed, let's see. Let's go to seed random. Okay, so this says the rand function is used to do this. If random numbers are generated with rand without first calling srand, your program will generate the same numbers. Okay, so we just call srand and that should seed it. And what's this saying? We need an integer. Okay, so we'll just use time. This is an unsigned int, so we'll say c get time as unsigned int. And this should be time null. Okay, so I'm going to copy that. And we should be able to do that. And that should give us a random number every time. Okay, let's see what happens now. And you have to head out, Asher. Thanks for coming to the stream, though. It was good seeing you guys, and hopefully you enjoyed it. Okay, cool. So this definitely did something. We got a world seed of 128, and now you can see that this is different. I kind of lost all the other chunks, though, so we'll have to see what's going on there. But yeah, so that's good. And then if I run this again, we should get something different again. Yeah, so now we got 130, so that's good, too. And thank you for following. UT Shab, and I'm gonna change my screen real quick. There we go. So that should be better. Okay, I completely did not see what I just did there. Let's do this again. Okay, so now we got 131. So it is changing every time, and the world is definitely changing. But for some reason, I'm only getting one chunk now instead of all the chunks, and we want to get all the chunks. So this should do that. Did I mess something up inside of chunk.cpp? Not sure. Let's set the seed manually for now. So if I set it to 0, we should get one thing. If I set it to 1, we should get something else, and so on. So let's see if this works right. Oh, okay. So we do get that if I do 0, and if I change it to 1, we should also get something. Oh, I think I know what it is too. Yeah, so we get something. Technically, it's moving because I put this in a dumb place inside a chunk. Yeah, we shouldn't be doing this here. We should be using actual world coordinates here because that'll change things up. We should be doing that here. So do x plus world chunk x plus seed. And that should give us what we're looking for. So now if I run it, we should get some random terrain and we should see it below us. And it should change every time. Okay, cool. So we have random terrain that is generating randomly, but not too random so that it actually looks nice. And yeah, that looks pretty good to me. Pretty happy with the way this is going so far. Let's increase the chunk radius. I think that sounds like fun. So I'll go into world.cpp. Let's increase to, we're doing 4x4 area now. Let's do double that. That would be 8x8, which is 64 chunks. And we need to go from -4 to 4 now. And if we run this again, we should get a lot more chunks now. Okay, it's definitely taking a longer time. So we're going to have to optimize some stuff because that took a while to generate the world, which may be because of the noise functions. So we're going to have to look into all that. But yeah, this is pretty cool. So like you can see, we get dirt and then we get all this stuff. And what we can do too is have like a different noise function for generating stone. So let's actually do that real quick. If we want to add stone into our, the way this works right now, we can go into block formats. And you can see this is how we add new blocks, which is pretty easy right now. So I'm just going to say stone, and I'm going to just make this identical to all the other stuff. So then this is going to be ID 5. Side is going to be stone. Top is going to be stone. And bottom is going to be stone. I think. I'm going to have to look at that texture real quick. So we can look in the texture formats just to see what we need to call these. And if I look for stones, we got black stone there. We got chiseled, polished black stone, sandstone, cobblestone, stone bricks, end stone. Let's do stone colon. And let's just use a regex so that this is a little bit easier. Okay, there we go. Stone. So that is right. Okay, so this should add stone into our block map, and it's going to have an ID of 5. So now if we go back into the chunk generator, we can say, so this is the maximum height, and then we're going to copy that, and we're going to say this is the stone height. And then that's a float. And we'll change that to that. So we'll have a different random number generator, and we might change the way we're going to do this. And why am I using OpenGL version 3.3? Basically because I learned from Thin Matrix, and I think he was using OpenGL version 3.3, so I just kind of stuck with that. But I think OpenGL version 3.3 is pretty widely supported too. So if we look at support for OpenGL versions by computer, let's see if we get something. So let's see if OpenGL tells us this. So we got context window, so all this stuff, history, version history. Okay, yeah. So if we look at 3.3, it was released in 2010. So that's 11 years ago. Oh, and this is like 2011. So yeah, I guess we could safely go up to like 4.1 or 4.0. And I think that's still going to be pretty widely supported. But like you can see 3.3 was released in 2009, 2010. Okay, yeah. So I guess I could probably go up to like one of these and I should still be fine. This adds tessellation, debug outputs. Oh, that's kind of nice. I might go to 4.1. Shaders with atomic counters. And then 2012 is when we get compute shaders. Yeah. So I might increase at some point. The reason I did it initially was just because I watched Thin Matrix's tutorials. I think he was using 3.3. So yeah. And you always use 4.6. I might check it out. I might try it out and see what happens. Okay. So for the stone heights, what we're going to do is generate the fractal 2. I'm trying to think of what the best way to do this would be. So we could just have this be like a mixture of both of these noise functions. So we'll do, it's this times this over something. I don't know. I don't really know what I'm doing here. We're just going to sort of play with this stuff and see what happens. So if I do this divided by that, we'll see what happens. But then I'll do if y is less than stone height, we'll do stone, which is 5. Otherwise, we'll do dirt. Otherwise, we'll do grass or green concrete. But yeah. So let's see what happens with this. And hopefully we can sort of start mixing and matching with noise generation functions. And I'll probably look into some like papers and stuff to see how people create interesting noise. But yeah. Whoa, that did not work. We just got stone everywhere. Okay. So I think it's probably because of the way I'm doing this. Parenthesize that. Okay, now if we go, it should hopefully do what I want it to do. And Flare YouTube says, are you going to do chunk generation and deactivation based on player position? I am. That's going to take a little bit because we're going to have to figure out what the most efficient way to load chunks is and everything. So probably save that for another stream. And you've seen Thin Matrix tutorials. Remember, he used an older version. He did too, which is why I sort of stuck with it too. Okay, so if we do this now, we should get some stone thrown in here. I guess we could add bedrock too at the bottom since we're at it. No, we're not getting any stone, so I need to change up the stone generation. Let's just do over 255. Let's see what happens then. Once again, I'm probably going to look at some papers this week over like how procedural generation works and see different methods people use so that we can play with some better alternatives and stuff. I definitely need to speed up this camera now too, like I think it was Tree was saying I should do. Okay, yeah, so now we're getting stone. And you can see that we get the stone sort of following the same pattern, just way lower. So yeah, if we wanted to increase the height of the stone, we could probably just change it. But yeah, we're generating chunks and we're getting some procedural generation, which is cool. Like I said, we also need to make sure that we change the insides, that we cull these faces and stuff, which shouldn't be too bad, but I'm going to save that for another stream too. I guess last thing I'll do is add in bedrock. And we'll add that to the bottom. So we'll say this is ID 6. Side is bedrock. Top is bedrock. And bottom is bedrock. And let me just make sure I got all that right. /b bedrock. Cool, so that's right. And then if we go back into here, we can say if y equals 0, then we'll use chunk data array expansion .id equals 6. Otherwise, we'll do this stuff. Okay, so that should give us bedrock on the bottom. just change that to bedrock. And this is stone. And if I change this to be a little bit higher or lower, we should get stone generating higher. So I'll do like 128. We'll see what happens. Or 127, I guess. And the stone is way too low. That is true. You guys wrote a lot. Let me read this real quick. So chunk generation probably needs a dedicated thread for smooth generation based on player position or the, yeah. So we'll probably move this to be multi-threaded and stuff in the future, but that's going to be in the future. For now, we just want to get it working and stuff and see what needs optimizing, because we're always going to run a profiler, because you'll be surprised at what takes the most time. Also, Thin Matrix, did I try Equinox? I have not, but I've seen his devlogs and stuff, and I'm guessing it's probably a really good game. So, and will I put the math project on GitHub at some point? The math project, oh, math animations? That is on GitHub, I believe. So if you go, I'm going to leave that up just so I have it. I think this should be on GitHub. See? Yeah, math animation. So if you want to play with it and stuff, it should be pretty easy to set up if you're on Windows. I haven't added support for other things. Basically, you should just run vendor / bootstrap, or actually no, you can just run build, and I think build does everything for. So if you just do like build.bash, it's going to check if you need to have bootstrap run, and then it's going to run it if you need it, and it'll print out help for you if you need it too, and then it should generate your project files and everything. So yeah, you should be able to just run like ./build.batch and run it if you want to. So if I did all my work correctly, then it'll be really easy to use. Let's see if we get bedrock real quickly. Yeah, you're good. It's hard to, I have to like minimize some of the repositories and archive the ones that I'm not using anymore, because I have way too many of them on GitHub. Okay, this is kind of cool. So I changed the stone generation, and now you can see that it kind of grows. So this might be cool if we want to do some sort of mountains, you know, have our own caves and cliffs. But yeah, so now the stone is much more varied, and it changes, and it looks like it grows a little bit taller. So yeah, I've got to learn more about noise generation. And then if we look at the bottom, we have bedrock, which is good. I think Minecraft randomizes it just a little bit so that it's like not just one line of bedrock on the bottom, which we might do too. But yeah, this has definitely been a good stream. One last thing I want to do is print out my FPS just so that I can see what I'm going at. I think that's in world.cpp. So if we go into update, yeah, we got float DT. I think I can set my window dot, let's see. We've got a window, right? I think. If I look in core, yeah, we got window.h. And we have GLFW window. Do we have just like a regular window though? Let's see. So in init, I go ahead and say all this stuff. Am I even using this? I don't think I'm using this. Yeah, so that's fine. I'm going to remove that. Okay, I think this is actually an application. I refactored some stuff and forgot about that. So if I go into here, yeah, okay, this is where we have the window. And what I'm going to do is just say window.setTitle. Do I have that yet? No, I do not. I'll add that real quick. And we're just going to set the title to whatever the FPS is, and then I'll change that up in the future. So just delta time. So let's go into here, add a function real quickly. Void set title. This will take in a const ** title. And then we'll go into window.cpp and just add that very quickly, which should be pretty simple. I can just do void window set title. And we can use GLFW set title. Let's see, set window title. There we go. No, window title. And this takes in the window, which I'm going to say is window * window, and title is going to be that title. And it's window pointer. Okay, cool. So that should be good. And so you guys said, love the mountain. Yeah, the mountain's pretty cool. And you were on Coding Minecraft. Yeah, I've got 2 different GitHub accounts, so that can get confusing pretty quickly. But yeah, so we got this window. Let's go back into application very quickly, because I just want to see what our frame rates are and stuff. This is gonna have to be a const char star now. So what I'll do is I'll just say stud string title equals Minecraft delta time, and then we'll just do plus delta time. Okay, cool. I might have to do a stud string around that. Nope. It's not gonna like that. Let's do whoops. I think it's like A2I or something like that. Gets it one way or another, but we'll do title.cstring. So that should be fine now. And this is not window, this is window pointer. So we should be good there. And then let's just see real quickly, C++, float to string. Okay, so we just use stud to string. Okay, there we go. Cool. So now if we do this, we should be able to see our frame rates and stuff. And that will be good just so that we can see how fast this thing is running once it starts. Okay, it's going. There we go. Cool. So what's it look like? It looks like we're getting 0.016. So we're getting 60 FPS. That's good. It'll probably be interesting to see how many chunks we can get and how many frames we can get. And then we'll optimize so that we can get as much as possible and still have it working. But yeah, that's cool. So we got 60 FPS Minecraft running a like 8x8 chunk area right now, which is pretty small, but we'll increase that. We have procedural generation, which is really cool. I'm going to look into some papers and stuff, see if I can find out how to make this better, and we'll implement those in the next stream. But thank you everyone for coming to the stream. I thought it was a ton of fun, and we're making some really good progress on this. So hopefully next stream we'll be able to increase or improve the noise generation and the world chunk generation sort of things. And then we'll try and start loading chunks in and unloading chunks as the player moves around and stuff. So yeah. Anyways though, I'll see you guys next time.